Hi everyone, I hope you're okay, and I really hope that guys the videos we keep uploading are helping you out. Please note that guys this is the 18th video, which simply means I'm doing question number 18. Please do expect a total number of 33 questions. Organic chemistry is a huge chapter, so please do expect many videos, and I do believe that guys the videos that I'm uploading, they will be helpful to you because all of them are extracted from the past exam question papers. So yeah, just click the link on the description below. For those who still want to learn organic chemistry from scratch, click on the first link, and then for those who want to just answer the questions, just click on the second link. On the second link there on the description, you will find all 33 videos. That's me answering all the 33 questions which are extracted from past exam question papers. Okay, before I even start this one, guys, you can just take a screenshot, attempt it on your own, and then come back and then compare your answers to mine. We are told that the boiling points of the same organic the boiling points of some organic compounds are given in the table below, and then Y represents an unknown boiling point. And then okay, let us analyze these compounds before we start answering these questions. Nah? We have methanol, ethanol, propane 1-ol, butane 1-ol, and then we have butane 2-ol, 2-methyl propane 1-ol, and then 2-methyl propane 2-ol. Okay, we are dealing with alcohols only here, guys. Nah? But I want you to notice something. From compound A to D, we are dealing with primary alcohols only. Primary alcohols are alcohols where the functional group of alcohols is found rather at the terminal carbon. Are you together? Please note that methanol has only one carbon, ethanol has 2 carbons, propane 1-ol has 3 carbons, butane 1-ol has 4 carbons. Are you together? And all of them have something in common. They have an OH at the terminal carbon. They are all primary alcohols. Are you together? Please note that, guys, the more you increase the number of carbons on your parent chain, you are increasing the boiling point as well. Are you together? This is compound A. It has a lower boiling point. Compound B has 2 carbons on the parent chain. The boiling point increases. And then compound C has 3 carbons on the parent chain. The boiling point increases as well. And then compound D has 4 carbons on the parent chain. The boiling point increases. Are you together? So for the first 4 compounds, we can conclude that by just adding more carbons on the parent chain, that increases the boiling point. Are you together? Okay, now let's focus on all the other compounds. If you can check from compound D until compound G, all of these compounds have the same molecular formula. Are we together? But these compounds are just isomers of one another. Some are positional isomers, some are chain isomers. Are you together? For example, compound E and D are positional isomers. Why? Because we have compounds that has 4 carbons on their parent chain. However, the functional group for alcohols is not located at the same position. For compound D, it is located at the terminal carbon, but for compound E, it is located at carbon number 2. Are we together? So compound D and E are positional isomers of each other. Okay, now I want us to look at compound D and F. Compound D and F are chain isomers of one another. They have the same molecular formula, number 1. Secondly, the the functional group of alcohols, whenever I compare G and D, the functional group of alcohols is at the same is at the terminal carbons for both. Are you together? The only difference is the chain is the structure of the chain. Are you together? Compound D is just a straight chain alcohol that is 4 carbons, but compound F is not a straight chain. Compound F is branched. At carbon number 2, we have our side chain there. Are you together? But everything else is the same. The only difference is that compound F and compound D are chain isomers of each other. Okay, now let's look at compound E and compound G. The first thing I want us to notice is that they have the same molecular formula. Are you together? From compound D, E, F, and G, their molecular formula is CfH10 with an O. Are you together? All of these compounds from D up until G, that's their molecular formula. But now we are contrasting between D and G. I mean E and G rather. The functional group is located in carbon number 2 for both compounds. Are you together? So these are not positional isomers, number 1. However, they are chain isomers. Why? Because compound E has all the 4 carbons on the parent chain. However, compound G has only 3 carbons on the parent chain, and then it has a side chain on carbon number 2. Are we together? So compound E and G are positional isomers of each other. Okay, now let's answer the questions. They want us to draw the structural formula of compound F. Compound F is 2-methyl-propan 1-ol. So it's propan 1-ol simply means that my parent chain has 3 carbons, and then in carbon number 2 I have a side chain like this. And then I was told that, okay, let me write the hydrogen atoms. Hydrogen. In the meantime, I hope you are subscribing lapho mntanami. Hydrogen, 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 hydrogen. And then we are told that at carbon number 1 we have our OH. So this will be the structural formula for compound F. Are we together? Okay, 3.1.2, they want us to write down the letter that represents the positional isomer of compound E. Remember that, guys, we did say that compound E and D are positional isomers. Why? They have the same chain length. The only difference is that the OH ion is placed in different carbons. Are you together? So the letter that represents the positional isomer of compound E would be compound D. Are you together? And then the letter that represents a chain isomer of compound E. Remember that, guys, we did say that the chain isomer of compound E would be compound G. Why are we saying that? Because compound G and E, the OH ion is located in carbon number 2 for both of them, and secondly, they have the same molecular formula. However, the only difference is their structural formula. Are you together? Compound E is a straight chain, but compound G is a branched chain. So compound compound G is a chain isomer of compound E. Okay, and then now we are being asked the boiling point increase, but the boiling point increases from compound A to compound D. Okay, we are looking at compound A and compound D. Remember that, guys, I did state that the first 4 compounds, all of them are just primary alcohols. Are you together? All of them are just primary alcohols. I was explaining it over here. That once you increase the chain length, you will be increasing the boiling point. Are you together? Why? Because you are increasing the surface area of the organic compound. Are you together? So we must give a reason, because there's an increase in the chain length. Increasing the chain length, or you can say increase in the surface area. Increasing the surface area. Okay. Name the intermolecular forces that, or name the intermolecular force in these compounds responsible for this increase. Since we are adding carbon and hydrogen atoms, guys, that means we are increasing the strength of London forces, because London forces only exist in hydrocarbons. By me increasing the chain length for my alcohols, I'm basically adding hydrogen and carbon atoms. So the only intermolecular force responsible for hydrogen and for the combination of hydrogens and carbons is just London forces. London forces. Okay, 3.3. We are told to consider the boiling points given below. You have 85 degrees Celsius, 108 degrees Celsius, and 122 degrees Celsius. Okay. From these boiling points, choose the following. From this boiling point, choose the boiling point choose the boiling point represented by Y in the table. Okay. Y is it has to be a boiling point for 2-methyl propane 1-ol. One thing, guys, I want you to notice about compound Y, is that compound Y is a branched alcohol. Are you together? So since compound Y is a branched alcohol, firstly, it has a lesser surface area compared to, not compound Y rather, but compound F has a lesser surface area than all the alcohols above it. Are you together? So I'm expecting to find a boiling point which is greater than this one. Why? Because please note that, guys, for intermolecular forces, primary alcohols are stronger than secondary alcohols. Are you together? So if I'm comparing compound F and G, these two alcohols, they are positional isomers of one another. Are you together? They have the same side chain. The difference is that the hydroxide ion is located in different positions. In compound G, the hydroxide ion is at carbon number 2, and then in compound F, the hydroxide ion is in carbon number. The hydroxide ion is in carbon number 1. Are you together? So compound G is a tertiary alcohol. Tertiary alcohol has the weakest intermolecular forces compared to secondary and primary alcohol. Are you together? Please note that I'm expecting I'm expecting Y to be greater than 82.5 degrees. Are you together? Why? Because F is a primary alcohol and G is a tertiary alcohol. Are you together? At the same time, I'm expecting Y to be less than 99.5 degrees. Why am I saying that? Because compound E is a straight chain alcohol. It has a greater surface area. Are you together? So since it has a greater surface area, it will have stronger intermolecular forces. So I'm expecting the boiling point of compound Y basically to be in between 82.5 degrees Celsius as well as 99.5 degrees. So any number that is between 82.5 and 99.5 is the one that represents Y. So 85 degrees would be the answer. 85 degrees would be the answer. Okay, now they want us to give out a reason on how we arrived to on how we arrived to our solution. Ne? Okay, where will I write this answer? Okay, let me write it here because I have too much space over there. Compound F ne? It's compound F, compound G, and compound E. Let's contrast between those three compounds. Compound F, G, and E. They all have a hydrogen bond. And then, however, compound E has stronger intermolecular forces because it has a greater surface area. Are you together? Compound E has stronger intermolecular forces compared to compound F and compound G. Are you together? So now I know that since compound E has stronger intermolecular forces compared to F and G, that means compound E will have a higher boiling point compared to these two. And in this case, yes, compound E has a higher boiling point. Are you together? Now I must contrast between F and G. Okay, compound F has stronger intermolecular forces than compound G because F is a primary alcohol. Are you together? So since compound F has stronger intermolecular forces than compound G, I can therefore conclude that compound F has a higher boiling point than G. At the same time, but it also has a lower boiling point than E. Remember that E is the strongest of the three compounds. Compound F is just in between because compound F is stronger than compound G, but compound F is weaker than compound E. Are we together? So the boiling point will also be in between between that of compound E and that of compound F. Are we together? So that's why we have chosen the answer which is between the boiling points of compound E and the boiling point of compound G. That's how, guys, we're supposed to answer that question. Okay, 3.4. Hydrogen bonding is represented for the relative high boiling points of compounds A to G in comparison with hydrocarbons of similar molecular size. Draw two structural formula of compound A. Use a dotted line to show the hydrogen bonding between the two structural formulas. Okay, for compound A, I have methanol, ne? Okay, what did they say I must do? Draw two structural formula of compound A. Okay, another one will be here. The hydrogen bonding will happen between these two OHs right together. The hydrogen bonding will occur there. Okay, how am I dot? And then now we are told that compound B is ethanoic acid, ne? Compound B reacts with propanoic acid. No man, compound B is ethanol, excuse me. Compound B is ethanol. We are told that compound B reacts with propanoic acid in the presence of concentrated sulfuric acid. Name the type of reaction that takes place. Whenever you are mixing a primary alcohol and a carboxylic acid, you are always forming an ester. So the type of reaction will be called esterification. Esterification, ne? And then 3.5.2, we are being told to write down the structural formula of the organic compound, organic product formed, ne? Okay, let me just show the reaction. It's not necessary because they want me to show the structural formula only of the product. But I want this to make sense to you. Hence I'm drawing. Hence I'm balancing the equation. This will be propanoic acid in the presence of concentrated sulfuric acid and mild heat. The concentrated sulfuric acid, guys, it acts as a dehydrating agent. So it will eliminate this part over here. Are you together? So we will end up having C with an O there, and then C with double O, like that. Just put the H, the hydrogens over there. But remember that this thing was eliminated. This will be the inorganic product which is formed. Plus H2O. You can write H2O, or you can write the water structurally. It's up to you, ne? So the structural formula of the organic compound formed would be this one, and its IUPAC name will be ethyl propanoate. That's how, guys, we're supposed to tackle this question. This was the longest question, but yeah, I really hope that, guys, the videos will keep uploading and helping you out. Just stay tuned, make sure you subscribe, and you share the video to your peers. Don't forget to like, and do ask questions on the comment section, and come up with alternative solutions if there are. Thank you for your time. Bye.